A home security device wouldn't be much use without being able to record video. Just as we've added a buzzer and a motion detector to the device, we're now going to add the ability to record video. Hopefully you can appreciate the modular approach that we're taking to implement functionality. The camera that we're going to be using is high quality with a fisheye lens. This means that we can capture more of the world than with a standard lens. The guidance given in this tutorial can be used to build many devices that require picture taking or video taking capabilities. As the microcomputing that we're using is really tiny, we're going to have to adjust the resolution and frame rate so that the computer is able to handle the video that it's recording. Every video recorded is actually just a sequence of images that are taken rapidly and then stitched together afterwards. The number of images that a camera takes in a second is called frames per second, or FPS, which you might be familiar with if you play computer games. To record video with the camera, we first need to attach the camera physically to the device. Then we'll install the required packages through the terminal, and finally we'll write a Python script to record video. This is the final stage of preparation to create PyGuard. Firstly, remove the camera from the ZeroCam packaging that it comes in. The camera itself is quite delicate, so be careful when you take it out of its packaging. Once removed, this is what the ZeroCam looks like. On the back are two self-adhesives, which you can use to stick the camera to things. To connect the ZeroCam to the Raspberry Pi, first unclip the camera connector at the end of the device. Be extremely gentle with this and only push away from the device, using your fingernails on the edges of the connector as I'm doing. Don't expect the connector to detach fully, it just needs a millimeter gap. Thread the end of the camera connector into the bottom of this clip. It should slide between the computer and the camera connector. Once you've slid it in, push the connector shut, exactly how you opened it on the edges. This should connect the camera to the device. Give the camera a gentle pull away from the device to check that it's properly secured. With the physical connection completed, let's install the packages required to record video. You don't need to remember how to install these packages. If you were to try to run the program without the packages we're about to install, it would fail and complain that the packages aren't installed. A quick search with the error message would tell you that you need to install the following packages. So don't worry about committing this next section to memory. Whilst connected to your Raspberry Pi, type sudo apt install ffmpeg. We'll use this package in our Python programs to convert video files to a viewable format. It will also be required later to combine the video and audio that we record. Once installed, type sudo apt install python3-pycamera. This package enables us to create PyCamera objects from the PyCamera class, which we'll need to record video. Give these packages a couple of minutes to install. Finally, enter sudo raspi-config. Use the arrow keys on your keyboard to navigate down to interface options. Press enter and then press enter again to select legacy camera. Then press the left arrow key and press enter once more. Select OK with enter and then press escape to return back to your terminal. What we've just done is enabled a camera, just like you'd do in system preferences on a Mac or settings on Windows. For these changes to take effect, we need to reboot the device, which we do using sudo reboot. This will cause your laptop or computer to disconnect from the device, which you'll see happen in the bottom right. Wait a few minutes for your Raspberry Pi to reboot and close Visual Studio Code. After a few minutes, reopen Visual Studio Code, select Open a remote window in the bottom left and then choose the IP address, as I'm doing here. Give the application a couple of minutes to reconnect to the device, which you'll see indicated in the bottom left. Then, open up Explorer and open up the Home folder on the Raspberry Pi. It might prompt you to connect and re-enter your password, which you should do. Once connected, check which folder you're in using the pwd command. If you're not in your PyGuard folder, as I'm not, then enter it with the cd command. Then, create a file in that folder called recordvideo.py, and finally, edit that file with the code keyword. Now we're ready to write the Python program to record video with our device. Firstly, let's import the PyCamera module that we installed earlier, and the datetime module for naming our files. Now, we'll start with defining a function called recordVideo, and this function will take the duration, video file, and frame rate. Now we'll create a camera object out of the PyCamera class, and we'll set the camera object's resolution and frame rate. Under that, we'll use the start recording method on the camera object to start recording. Then we'll use the wait recording to specify how long we want to record for with a duration variable. After that, we'll stop recording with the stop recording method and close the camera object. We've added a couple of print statements so we know what our program is doing while it's executing. Before we call the function, we need to create the variables that it's expecting: duration, frame rate, and video file. Once again, we use the timestamp variable to ensure that the video file name is unique, just as we did with the audio recordings. Finally, we complete our program with the record video function call. Unfortunately, currently this program will create files in the H.264 format. Therefore, we need to convert these files to MP4. To do this, we import the subprocess module to allow us to run bash commands. We need to edit our record video function so that it returns the video file. And then we'll create a function called convert to MP4. This function takes the old video file as input and converts it to an MP4 file. Then we need to create the MP4 file name, as we created the other video file name. Because we're now returning a value from the record video function, we can set this value as equal to a variable. And finally, we can call the convert to MP4 function using the variable that we created on line 46. Remember to save the program before you run it. If your code is identical to mine, then pressing the play button in the top right will start a video recording for 10 seconds. You can see on the left immediately a file with the H.264 format is created. Once the 10-second recording is complete, this file will be converted to the MP4 file that you see here. Great job if you managed to follow along and record video with your Raspberry Pi. I appreciate that we just wrote quite a bit of code and that it could seem daunting. I just want to reiterate the two most important concepts from this Python program that you should take away. Firstly, I want you to remember the power and importance of creating objects from classes like the camera object from the PyCamera class. It's an important concept to remember that in programming, teams of highly skilled programmers create complex classes like the PyCamera class. And all we have to do to use the functionality that they've built is create an object from their class. The power of these objects come from the methods that the classes contain. We're going to learn much more about these methods and where to find them in the next tutorial. The second concept that I'd like you to remember from this tutorial is the importance of functions. We ended the record video function with a return statement. This enabled us to save the output of that function to a variable, which we then entered as an input in the convert to MP4 function. Through using functions, we've isolated the functionality of our code. If, for example, the file doesn't convert to MP4, then we know that the problem resides in the convert to MP4 function. In this tutorial, we installed the required packages to record video. Then, in our Python program, we set the resolution and frame rate to match the power of the hardware that we're using. And finally, we combined functions, variables, and object-oriented programming to create a program that recorded video and converted it into a viewable format. Next, we're going to look into the methods that have been making our lives so much easier.